In the next set of videos, we're going to talk about car loans, and it's going to use a lot of the same math that we used in the previous section about annuities. And it's because a car payment is kind of like an annuity, that it's a fixed string of unchanging payments, or what we call a fixed installment loan. But notice there are some differences between the two formulas. This is the annuity formula. And so annuities we're going to make some payments, and it's going to give us a future value of money at some point in the future. And that's not the way cars work. Cars are not based on what their future value is. They're based on what their present value is. And so notice how A was our future value in the annuities formula, but notice we have P, the present value of the car today, is what's in the numerator. And also the denominators are kind of reversed. They're almost like mathematical mirror images, or what we call in mathematics inverses of each other. But they do work off a lot of the same math and the same terms and the same variables that we used before. So we have this problem here that's one of the more complex versions of a problem, which is why I chose to include it. And so we have this new car we're going to buy for $64,000, and that includes taxes and license fees. So you pay $12,000 for a down payment. So the first thing we need to do for either one of these scenarios is go ahead and take $12,000 off of this, because that will not be part of the amount that's financed. So when we take that off, we come to $52,000 is what needs to be financed, and we're talking about the financing here. So the dealer is offering a choice between two incentives. You have incentive A. They'll give you $7,000 off the price of the car, and you take a 5-year loan with them at 5.94%. And this is very common with car dealerships. Incentive B does not have a cash rebate, but it will give you interest-free financing for 5 years, and you want to find out which one is the better deal. So with an incentive A, we're going to take $52,000, and the very first thing we're going to do is take $7,000 off the price. All right, they're going to give us a little bit of a pile of money here, so we can take their loan that has interest on it, because they'd probably rather have our string of payments, and maybe this interest rate is something where they're going to make more money back. Maybe we'll make more than the $7,000 on us in interest. So let's see. And with option B, we have $52,000. There is no rebate given, and in fact, since the financing is free, or no interest over 5 years, this is really simple to figure out what this car payment is, because it's $52,000 and you're going to pay it in 5 years, paying every month. So you're going to divide $52,000 by 60 to get that car payment, and I've already done that, and it's $866.67. All right, so that's going to be that car payment. That one's very simple to calculate. So over here on option A, let's calculate a 5-year loan at 5.94%. So let me go get the formula and we'll populate it. Formula says P parentheses r over n, 1 minus 1 plus r over n to the negative nt. So our P is this 45,000 number. So we got 45,000 times r. R is 0.0594. Since car payments are paid every month, we're going to divide that by 12, because that's n. Then we divide that by 1 minus 1 plus r over n to the negative nt. So when we populate those values, this is what we get. Now we need to put this into our calculator. We're going to be very careful here, as always. Okay, so we'll put 45,000, and we're going to do parentheses, 0.0594 divided by 12, close parentheses, divided by 1 minus, and then another parentheses, 1 plus 0.0594 divided by 12, close that parentheses. Now we're going to raise to the power, and again, this is always that tricky part where we got to raise to the negative, and we need to put parentheses 12 times 5, or either just put negative 60 if you want to do that math in your head. And now we'll close the last parentheses, which is the big bracket, and we press enter, and we get $868.72. So we want to find the difference in monthly payments between these two offers to find out which one's the better deal, and you can see they're very close to being the same. So the difference is $868.72 minus $866.67, and so we see that the difference in payments between the two offers is rounded to the nearest cent. Is going to be just $2.05. So in this case, these two incentives are pretty similar, but you should always check, because in fact some of you may get various iterations of this question, and it'll have where the difference is much greater, and in some cases incentive A is going to be better, and in some cases incentive B is going to be better. So just look at your particular example and work it this way. Now, one last thing I do want to show you is that you can use Microsoft Excel. So you may recall from the annuities video, we have a built-in Microsoft Excel function. So if you click here on the formula function bar you can insert a new function, and we're going to pick the payment, because that's what this is. In fact, it uses the letters PMT, and another way to find your functions in Excel is to type your description. Just type in PMT, and it brings up all the ones that are related to payments. So we pick PMT, and our initial amount of the loan, our rate is the first thing we put in. So the rate was 0.0594 divided by 12, because we have to do R divided by N as in the formula here. The number of periods, that's n times t, so that's 60 periods, because there's you can even put 12 times 5 and it knows that's 60. And so you may recall for annuities we left present value blank and we put in future value to find some payment. And so here we actually have a present value because the present value of the car is what it is worth now. So recall for incentive A, the $12,000 down puts at $52,000, and then we take $7,000 more off, and so our present value will be $45,000. And you see we get that same number, $868.72.